6.4, properties of logarithmic functions. First thing we're going to do is a couple properties. Product and quotient properties of logarithms. For m greater than 0, n greater than 0, b greater than 0, but b cannot be 1. The product property is log base b of m times n is equal to log base b times m, or of m, plus log base b of n. The next one, or for example, if I have log of 5 times 4, what does that really mean? Well, what's my base? Log base 10. We don't write the base 10, it's just a given. I could take on my calculator and do log of 20. Log of 20, it's 1.301. But log of 5 plus the log of 4. Log of 5 is 0.699. Log of 4 0.602. If I add these two together, what do you get? Same exact thing. The only difference is mine's rounded. That's what the log of 20 is. Guess which one's coming next? No. Quotient. Again, same things. You don't have to write this over. The quotient property is if I have log base b of m divided by n. It just means log base b of n minus log base b of n. For example, I have the log of 5 divided by 4. We treat it just like exponents. When you divide, you subtract. Now, if I take the log of 5 divided by 4, it's 0.097. This just means the log of 5 minus the log of 4. Log 5, we know is 0.699. Log of 4 we know is 0.602. When I subtract you, I'm just going to go second enter, change the plus. Actually, I'll throw the minus here. And I get same thing, 0.097. It has to be, if it's 5 divided by 4, the 5 has to come first. Here's this one. I have log base 3 of 8 plus log base 3 of 7. We can't do this right in the calculator. No, calculator cannot do base 3. What does it mean if it's plus in between and they have the same base? Log base 3 of 8 times 7, which is log base 3 of 56. That's all we're doing right now. That would be our answer right now. Does...
I didn't say why, I said wow. They always in somebody's mouth.
Because what I have, if I even change this to exponential, is 3 to the x equals 56. Like, it's not common. This one here. Now there's pluses and minuses here, so you have to be careful. I have log base 15 of 4x plus log base 15 of 3 minus log base 15 of 6. So this means log base 15 of 4x times 3 divided by 6. The plus means times, the minus means divide. So this actually means log base 15. 3 times 4x is 12x. What's 12x over 6? 2x. So it's log base 15 of 2x. That's as far as I can go. When you subtract common bases, you divide. When you add common bases, you multiply. Same thing as before, except for now I have a real number p. Log base b of m to the p. This means p times log base b of m. What happened to my exponent? What happened to my exponent on the m? For example, I have log 100 to the 4th power. What does to the 4th power really mean? Times 100, times 100, times 100, times 100. So I really have log of 100 to the 4th is log 100 plus log 100 plus log 100 plus log 100. What do I really have there? What's x plus x plus x plus x? 4x. So it's actually 4 times log of 100. That's right here. This means I have log m p times. So it's just p times log of m. So what's the log of 100? You shouldn't need a calculator. Okay, what does log mean if it's not written there? What's the base? 10. What? Why 2? Log of 100 is 2 because 10 squared is 100. So it's actually 4 times 2, which is 8. So this meant 2 plus 2 plus 2 plus 2. If I have an exponent, it's just whatever that original log was times by what the exponent was.
Oh, you able to add that p in front?
Because this right here, log of 100 to the 4th, means I have 4 of these. 1, 2, 3, 4. Each one of these is 2.
So basically, whatever log on exponent, we'll solve the log part.
Right, you solve the log part of it and multiply by the exponent. Log base 6 of 36 cubed. And I also have log base 4 of 256 to the 11th. All this really means here is 3 times log base 6 of 36.
No, it's 2.
2. 6 squared is 36. So it means 3 times 2, which is 6 is my answer.
Wait, time out.
How'd you get the answer?
The last one, why did you do? Alright, you took the 4 from the problem, then you multiplied it by 2 to get 8. So why did you do that again?
Oh,
Where'd the 4 come from?
the exponent.
The exponent.
How do you know that?
Now, for the second one. Okay, so this means 11 times log base 4 of 256. 4 to the what is 256? Let's see, 4 times 1 is 4, times 2 is 16, times 3 is 64, 64 times 4 is, so 11 times 4 is, that's your answer. No calculator needed. Exponential logarithmic inverse properties. I have log base b of b to the x is just equal to x. B to the log base b of x is just x. Explaining this. Now, base b, what does this mean right here with an exponent? Rewrite this. X times log b to, or of b. Okay, b to the what is b? First. So it's x times 1, which is
X to the first.
x.
You weren't.
Do you understand? X times log base b of b. B to the what is b? 1. It's x times 1, which is just x. That's explaining it. I could make these 6s. How many, what's 6? 6 to the what is 6? 1. 5 to the what is 5? That's what it's saying.
So if it was so if it was 1 to the 1 is 1.
Correct. But b cannot be 1. Yes, that b is tiny. B to the log b all right, b log b of the x. So in other words, b to the log of b, base b. Again, what happens here? This b is, or this x is actually going to go. What happens here? And I'm just left with. Right. That's what we did here. Here. I have 3 to the log base 3 of 4. Plus, it has to be small, or it doesn't look like an exponent. Plus log base 5 of 25. 3. For the first one, log, or 3 log base 3 of 4. What happens here? The log base 3 and the 3 cancel out. I'm left with 4. What's log base 5 of 25? 2. Why is it 2? 5 squared is 25. 4 plus 2 is 6. Log base 2 of 32? Let's see, 2, 4, 8, 16, 32, 5. Minus 5 or log base 5 of 3. That's gone. I'm left with 3, which is 2.
Which is 2, that's
What is the log don't match the base?
If the log does not match this base, like if this was a 7, we can't do that. Can't do that as of today. One-to-one property. One lesson.
How many cell lessons?
These are all properties. Remember the title of the lesson was Properties of Logarithms.
Would they have like 10 exponential functions?
Log base b of x. If it's equal to log base b of y, then x has to equal y. Remember before we did, if I had 2 to the x, 2 to the 5. What's x equal to? Y. They had the same bases, they canceled out. You're just left with x equals 5. What do you notice here? They're both base b's. So the bases, they're the log with the same bases, cancel out. I'm left with x equals y. That's all I'm saying.
Wait, you can't just explain stuff while people write. Yeah, I wasn't paying attention.
For example, I have log base 3 of x squared plus 7x minus 5 equals log base 3 of 6x plus 1. This is where you have to be careful. This problem here, the bases do not disappear. You notice that? If you just have log base 15 of 4x, log base 15 of 3, log base 15 of 6, you have to do, because it's addition, you have to multiply, subtraction, you have to divide. What's different here? They are equal to one another. This whole side has to be the same base as the other side. Both of these are base 3s, right? The log base 3s will cancel out. I will be left with x squared plus 7x minus 5 equals 6x plus 1. No. Well, I'm going to move everything to one side. X squared plus x minus 6 equals 0. If you need to do the little math, do the little math. Minus 6, minus 6x, minus 1, minus 1. I moved everything to one side. Now what do I need to do? What's my first step?
No, 1 times 3.
First thing I look at. First thing I'm going to look at, can I pull anything out? No. Is it special? Why not? Can't take square root of 6 evenly. Okay, now since it's nothing to pull out, it's not special, I have a bunch of options. I can A, factor, complete the square, quadratic formula. Well, this one, I'm going to try to factor it. Let's see, only way to get an x squared is x and an x. This tells me signs are different. Two numbers that multiply to get me 6, but subtract together get me 1. Which one's 2, which one's 3? 3 is plus, 2 is negative. My answers are -3 and 2. Correct. This catches on to the prior knowledge. Quadratics. Open your books to page 382.